Today, we are going to be talking about a project that Ronnie, he's on the call. He's been working on what we're calling the Daft Launcher. We've had a lot of feedback around, hey, Daft is cool. It's fun to run it on a single machine on a laptop, but how do I kind of get started in a distributed context, right? How do I run Daft in a distributed cluster? And so we've been building this project called the Daft Launcher, which will help us launch Daft very easily. Under the hood, it's running a lot of Ray, but we try to abstract that away from the user. And it's just, hey, if a user, you come with AWS account and we give you distributed Daft. That's kind of the idea. And yeah, Ronnie, why don't you go ahead, share your screen and take it away.
Sure. Yeah, I'll just introduce myself. So my name is Ronnie. I recently joined Eventual, and one of the pain points that I've been hitting is running Daft in a distributed fashion. Yeah, the tool that I've been working on recently is trying to like alleviate some of those pain points. Let me share my screen. Yeah. Anyways, I'll just create a project, Daft demo. Yeah, so just a little bit about like the Daft launcher. It's essentially just a way of being able to quickly spin up a distributed cluster and be able to submit jobs to that cluster. Currently, we're supporting AWS, but we have a roadmap for supporting additional cloud providers in the future. But yeah, I'm essentially just going to go through a very quick demo on the commands that Daft Launcher supports and how you can use it. So first, I guess let's just start by initializing a UV project. So I'm just going to initialize a Python project. And as you can see, like it just creates some pretty default like things over here. Just going to clear this for now. So I'm just going to create a venv source that, and then I'm going to do add get Daft or Daft inside of there. And as you can see, like Daft has been downloaded. I can go inside of here and, for example, import Daft. Now my ID will throw an error. Let me just fix that. All right, so Daft has been installed, and let's just do like PyDict. Let's just create some like kind of values, and then what I can do is, for example, df dot with a column, like let's say result dot call values dot root. Sure. So essentially, yeah, I just created a little expression, just take the values column, can be the cube root. And let's try to run that. So once again, we're running on a single machine right now, but you can see this is kind of like the output that we're expecting. Now the problem becomes, okay, well, I want to try Daft out in a distributed context. How do I exactly do that? Well, right now, one of the ways that you could do it previously is that you could have used Ray and then like troubleshooted with all of the very intricate sort of pieces of knowledge that you needed to know about Ray in order to get up and running with running it in AWS or GCP. But one of the tools that we've been working on is Daft Launcher. And what you can do is you can install the launcher that installs the latest versions. And from your terminal, you can actually see that once it's installed, a whole bunch of commands which are available to you in order to actually get up and running like a distributed cluster in AWS. So these are some of the commands which are available. There's 6 right now. For example, you can see like up and down, which spins a cluster up, down, which spins a cluster down. You have some nice ones as well, such as like list, which lists all of your running or terminated clusters. Submit, which allows you to take a working directory and submit it to your cluster, as well as a dashboard, which allows you to establish like a port forward from your local machine to the head of your Ray cluster, which allows you to interact with the Ray dashboard, as well as a nice little convenience command that allows you to initialize a configuration file. So first, let's just start with initializing a configuration file. That's kind of like the entry point into Daft Launcher. So what I'll do is I'll do daft init config, and that will initialize a .daft.toml. over here. As you can see, there are some pretty like basic minimal configurations and a nice little helpful error message that's printed out to the top. But as you can see, most of these are optional because there are some pretty sensible defaults that we have internally inside of the Daft launcher. For example, like the region defaults to US OS 2, the SSH user, the EC2 user, et cetera, et cetera, et cetera. But anyways, let's just start simple and let's go with an AWS provider and let's set the name of our cluster. So let's call it Daft Contributor Sync Demo. And finally, once the actual cluster is up and running, we can actually send it some additional commands to run after that's done. But, I'll just keep this in for now. Obviously, echoing doesn't really do anything too valuable. Now that we've run Daft init config, we can try running Daft up. So let's do Daft up help just to, explore. So what you can do is you can pass it like a custom config path, or if you don't want to pass it that argument, it will try to look for a .daft.toml in your current working directory. If you do Daft up, it will actually start spinning up that entire cluster given your configuration file over here. So once again, there's not many configurations in here, but the point is that there's a whole bunch of sensible defaults underneath the hood. So I've noticed that this command usually takes around like 30 to 35 seconds just to spin up the entire cluster. It will spin up one head node and two worker nodes, and then it will proceed to download all of the appropriate dependencies inside of each one of them, specifically Ray as well as Daft. You can see some of the packages that are being downloaded right now, and we will finish in around 5-ish to 10 seconds.
Pretty sleek.
Yeah, it's very convenient. It's just a very simple command, and we are essentially done right now. There we go. So let's again look at all the commands which are available. One that I want to point out right now is list. As I mentioned before, Daft list lists all of your clusters, whether they are terminated or running, etc. There we go. So I have a couple which are running right now, and it tells you some pretty cool information about them. Specifically, this is the one that I created right now. This specific instance is the head node, and this is the public IP that I can reach it at. Whereas these two are the worker nodes. So I mentioned that the default configuration file will spin up two worker nodes. So now that I've listed my instances in my cluster, I can also submit jobs to this cluster. Let me try to walk through that. Daft submit. So I can pass in my identity file. This essentially enables the port forwarding. I can pass in the working directory, which will be, for example, like this current working directory. And then I can pass in the actual command that I wanted to run at the end of the day. So one thing I'm going to do before I package up this entire working directory, I'm actually going to create a subdirectory. Let's just call it source. And then I'm going to move hello.py source. And then I'll do that entire. Okay, looks like I've run this command before. So I'm just going to tab complete that and then hello.py. All right, so the job has been successfully submitted to the Daft contributor sync demo cluster. Yeah, so I can submit as many jobs as I want. I can put any arbitrary command to run over here. But now the question is, now that I've submitted a job, how do I actually view it, right? Like I see that this job ID of 625BQ has been submitted, but how do I see the progress of it? So another command that I have exposed over here is dashboard. And what dashboard will do is it will enable a port forward from your local machine to the head. It will port forward specifically port 8265, according to the Ray protocol that allows you to view the Ray UI, the browser UI. Let me do Daft dashboard, and I'll tap to autocomplete, but I pass in the identity file so it can establish that SSH connection. And as you can see, it has worked. It's just hanging in the background. And I can go over to my browser. I can navigate to localhost 8265. And I can see essentially that exact job that I was running previously, 625BQ. I can view that job. As you can see, this is the exact same output that I saw while running locally, but this time it was running distributed. And I can see that this job has succeeded. I can also run other jobs. For example, let me open up a new terminal, and then I can do Daft submit instead of Python hello.py, let me just do a simple ls of the working directory. So you can see that job has been submitted and the ID is going to be B5UM9. And over here, if I go back to my jobs, B5UM9, let me look at the logs of that job. And as you can see, essentially just printed out the working directory. And as you guys could probably tell, this is the hello.py that we zipped over and sent over. And once again, it succeeded. You can kind of see the progress of jobs, if they're pending, if they're succeeded, if they've failed. I can do an example of a job which will fail, for example, if I put some random garbage. If I go over here, I can see that it's running. And then after a quick second, you'll see that it failed because there's no command called astf, blah, blah, blah. Anyways, so let me kill that dashboard. Activate this and kill this terminal. And finally, so I've gone over up listing clusters, the initialize config, submitting jobs to it, as well as the dashboard command. And finally, we can bring down a cluster using daft down. And that will look at my configuration file. It'll see that, okay, the one that's running right now is that daft contributor sync demo. It will attempt to bring it down. And after usually 10 to 15 seconds, it pretty much kills everything. And after this is successfully brought down, we can do a daft list. And as you can see right now, these instances in our cluster are currently shutting down. In a couple of seconds, they will be fully terminated. So right now you can't reach them, you can't SSH into them, but in a while they'll be fully terminated. That's kind of like the whole process of bring up and bring down of clusters using the Daft Launcher tool. So currently right now, we're only supporting AWS, but there's a very clear roadmap of supporting GCP and other cloud providers in the future. But yeah, that's kind of like the quick demo. We're planning on releasing an MD book that users can navigate to and they view all the commands that you have over here, like an example of how to actually run through them, as well as like feature plans. So this MD book is currently in progress, but we're planning on releasing that soon. That's pretty much the demo.
Good job.
Thank you.
It looks real clean. Yeah, looks pretty good. I think we had a couple of questions, especially from Kimberly, who was asking, do we have any plans around like how do we monitor the job, right? Because you showed us we were able to go onto the Ray dashboard to see it, but that does mean that users might have to understand Ray, might have to understand, potentially actors and tasks and all that, right? Is there any plan maybe of us? Maybe this is a question to the wider team too. Like how do we think about observing a Daft job? Yeah.
I think one of the tools that we're thinking about, or one of the features that we're thinking about implementing, is having an open connection. So when you submit a job, having a lasting connection to that job submission, and essentially all the standard output from that job will be directly sent back to your terminal. So when I do like daft submit, blah, 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 that opens up a connection, like a TCP connection or whatever. And then as the standard like printouts happen on the head, those printouts get sent over to us. So that's one way of monitoring your job progress without necessarily knowing too much of the internals of Ray. It's a very simple way that we're thinking about incorporating. Yeah.
Are you thinking it would be similar to Docker Compose? Since it's running in a distributed fashion, you would have that rely on the prefix by which node is creating it?
Sorry, could you mention the last part again? I think you cut out a bit.
Yeah, so Docker Compose, when you run multiple things together, it will, when it's printing things out to standard out, it will prefix it by the process that is producing that standard output. Do you think we might have something similar where, since this is running in a distributed fashion, would we like prefix it within the node that is creating that standard output?
Yeah, potentially. I mean, like I'll need to look specifically at the array internals and see how we can actually get like the node name, which is producing that. But yeah, that's definitely something that we can try to incorporate.
Yeah, I guess for now, the first step would just be to get just standard out of like that process that we're running on the end node. But Ray actually does produce a lot of different log files on each worker and on the head node too. So I think we have to just be very careful about which ones are probably going to be good for user facing logs and which ones maybe if a user requests it, we can then like show them here, like here's standard error from like one of the workers, right? So
Yeah.
it is complex though. Distributed system logging is like.
I think Ray does a pretty good job actually at this, which is like, I think if you do print, you start like print and then within Ray, within a task, it will actually print out like the machine or the actor or the task name as a prefix already.
Yeah.
So I think it really does that. I think, because you probably know the node is like, the node doesn't really matter. It's actually more about like a task. Yeah, and
exactly.
more of the task or the actor that you care about.
Exactly. Yep.
I think Kevin had another question.
Yeah, I think Kevin asked how big are the artifacts in each machine? Is it just Ray plus Daft? Yes, currently those are like the default installations when you spin up a cluster, but you can also specify some custom dependencies that you can also download. But yeah, just without any additional dependencies, it will just be Ray and Daft.
Yeah, so I think Ronnie, our setup command thing in the toggle, that's what someone would use if they wanted to install something custom. Is that right? Or
Correct. Yeah. There's also a dependencies field. So that dependencies field, you can just specify the dependencies and we'll use UV to install it. But if you want, you can also go into the setup commands and actually manually write out like pip install this, pip install that, and do whatever like arbitrary commands, run whatever arbitrary commands in there.
makes sense.
And Kevin, I think the size of the Daft binary is somewhere in the order of like 20-ish megabytes, 20-30 megabytes.
Ray is a lot larger though, I think, and
Yeah.
Ray obviously also has a bunch of dependencies that it will pull in. So you can expect the size of that to be pretty large. But the good news is because we're using UV, everything is so fast. It's like the downloads are. Do you know how long these downloads take, Ronnie? I'm just seeing them blaze through in like less than 5-10 seconds.
Yeah, the actual downloads takes less than 5 seconds. Yeah, as soon as you see like the UV downloads happening, they're very, very quick. Yeah.
Yeah, for sure not sport size, for sure. I think there's other things too we can do, which is we can probably pre-generate a lock file for UV, because I'm sure UV is spending some cycles doing like dependency resolving too. And if we do that, then it might get even faster. Yeah.
You could do containers. Actually, what we found, Kevin, is that because of these new Rust-based Python tools, it's actually doing UV and fetching all the wheels is faster than sequential pooling image or unlayering images in the container.
Yeah, and also the problem with containers is that it makes the deployment story really difficult, right? Because we have to go to a user and say, hey, like, in addition to EC2, you also need to give us access to your ECR, like container registry, or if you have an internal one in your company, we need access to that. Like, all that's really difficult. And so for us, the goal of this project was like, hey, we just want raw EC2, right? Just give us the raw machine, and then you can kind of kick the tires on Daft and get up and running in a really fast way. Yeah.
And then the actual, because we're pulling up raw machines, because our AMIs don't need Docker, they don't set the Docker daemon.
Yeah.
That also gets faster boot up as well.
Yeah, and I know Desmond here will probably also remark that if you spin up Spark, it's not just pulling down the dependency, it's starting the JVM and all of that, that's gonna be slow, right? So the nice thing about us is because it's all Python and Rust and wheels, just download it and like start running essentially. It's fast.
Yeah, I mean, I think as time goes on, because we'll probably shift away from like these dependencies, and like in the end of the day, Daft would probably just be one glibc binary that you can just invoke, and that's it.
No more Ray.
No more Ray, no more these other things. Yeah.
That's the dream. Yeah. Cool. I think that was it, unless other folks had more questions. I guess Vignesh and Garrett, you'll recall any thoughts, any remarks?
Yeah, I think it's super cool. Like we had to kind of bake our own solution with Metaflow, which
Yeah.
would bake in like our first party like monorepo dependencies with third party PyPy. Which kind of does the same thing, right? It just kind of packages, like uses poetry to figure out all your locals, shove them into a working directory and shove them up. So it'd be interesting to see how we could integrate this and convince our infra dev team to maybe consider UV.
UV is great.
Yeah.
Highly recommend.
So Gary, they just launched, the team at UV just launched essentially the equivalent of poetry lock. It's called like UV lock, and they create like a similar like, full like transitive dependency lock file they can then install. And it's pretty good. It's pretty slick.
Yeah. It came just too late. And it's like, sorry, like We already did this. Not doing it again. No,
Yeah.
but yeah, super
And-
cool.
and
Yeah.
Y'all run everything on Kubernetes, right? So the way that we do it in this launcher is all just EC2, but I guess you're doing Ray and Kubernetes and Metaflow on Kubernetes and all that.
Yeah, ours is kind of like custom poetry decorator for Metaflow, custom ray job decorator, which essentially points at some already running ray cluster, and then it uploads the code package and then executes it. So it's very, very similar. It's just like we had to fit it in like this more general workflow definition tool. Yeah. So
Nice.
maybe they converge in some way to make it faster. Because I have noticed one challenge we have is bootstrapping in Metaflow for non-ray steps is very, very slow
Hmm.
in general. So maybe we can leverage some of this work in some way to make everything faster. So thanks for sharing.
Cool. Yeah. Okay. I think that's it. Thanks for coming, everyone. Catch you all next time.